Hey, welcome. So if you've ever tried to read a scientific paper, you know they can be dense, right? But what if I told you the key to the entire study, the secret to figuring out if it's actually any good, is hiding in a section that most people just skim right over? Let's dive in.
So, take a guess. What do you think it is? The introduction that sets the stage, the results section with all the flashy graphs, or maybe the big, thinky discussion at the very end? Now, don't get me wrong, those are all super important. But the real engine of the whole thing, the part that makes the science actually work, well, it might not be what you think.
And there you have it. It's the methods section. It's not the most glamorous part, for sure. But as researcher Richard Kallet points out, it's everything. This is where a study has to show its cards and prove it's legit. Think of it less like a boring list and more like the foundation of trust. And today, we're going to learn how to build the perfect blueprint for one.
Okay, so before we get into the nuts and bolts of how to write one, we really need to get our heads around why it's so important. Why is this section called the heart of the paper? What is its real job?
To put it simply, this is where you show your work. It's you laying it all out there, saying, hey, here's exactly what I did step by step. It lets any other scientist on the planet look at your process and decide for themselves if they can trust your results. It is, without a doubt, the ultimate test of your credibility.
And that test really boils down to two huge concepts. First up, reproducibility. Is your explanation so clear, so precise, that another lab could follow it like a recipe, and ideally get the same results? And second, validity. Does it give your reader enough information to look at your experiment and say, yep, that looks sound. The conclusions they drew actually make sense.
All right, before we can start building our blueprint, we have to make sure we're all speaking the same language. Let's quickly go over a couple of core concepts that are the absolute bedrock of any good method section. And it all starts right here, with the variable. Super simple idea, but it's the foundation of everything. It's just anything in a study that you can measure or change, anything that can have different values. And these variables come in three main flavors. You've got your independent variable, that's the one you control, the thing you're testing. Then there's the dependent variable, that's the thing you measure to see what happens. So for example, if you change the oxygen a patient gets, that's independent. You'd measure their blood oxygen levels to see the effect, that's dependent. But then you have the tricky one, confounding variables. These are the other sneaky things like, say, the barometric pressure in the room that could also mess with your results if you're not careful.
So you've run your experiment, you were careful, you controlled for those sneaky confounding variables, and you've got your results. Great. But how does anyone, including you, really know that those results are credible, that they mean what you think they mean? Well, that brings us to another huge idea. Validity. And it really has two different faces. On one side, you have internal validity. This is all about your experiment itself. Did you do a good job? Was it designed well? Did you avoid those confounding variables? It's all about whether this specific study is believable. But then you have external validity, and that's the bigger question. Okay, cool, it worked in your lab, but does it apply to the real world? Can we take these findings and generalize them to a whole population? A truly great method section has to prove both.
Okay, now that we've got the theory down, it's time to get practical. Let's actually build this thing. Here is the simple, clear, 5-step blueprint for a rock-solid method section.
And here it is. It's just a story, told in chronological order. It's that simple. You start with your ingredients, the materials. Then you talk about your prep work. After that comes the main event, the protocol, which you actually did. Then you explain how you measured everything. And you finish up by explaining how you crunched the numbers, the analysis. Let's look at each one. Step 1 is your shopping list. Materials. Who or what did you study? If it's people, you got to include their demographics, age, gender, health status, and exactly how you chose them. For your equipment, be specific. Don't just say a ventilator, say which manufacturer and what model number. And this last one is non-negotiable. You absolutely must include a statement saying you got ethical approval from an institutional review board. No exceptions.
All right, next up we have preparations and protocol, and these two really go hand in hand. This is the narrative of your experiment. Preparations are all the things you did to get set up. The protocol, that's the play-by-play, the exact step-by-step sequence of what you did and when you did it. And here's a pro tip. Use what's called a purpose procedure format. Just briefly explain why you're doing something right before you explain how you did it. It makes it so much easier to follow.
And finally, we get to the numbers with measurements and analysis. You have to be crystal clear about what you measured and how you measured it, including things like how you calibrated your equipment. List out any calculations you used.
Then, state what statistical tests you ran to make sense of all that data. And this is a big one. You have to specify your p-value. That's basically the finish line you decided on before the race started to tell you if a result is statistically significant or if it could have just been random chance.
So, we've got the blueprint, we've got all the pieces. But how do you put the words on the page? Because the way you write this section is just as important as what you put in it. The goal here is just one thing: perfect clarity. Remember these 3 words. This is your mantra: clarity, precision, order. Every single sentence you write should serve these 3 goals. This is not the part of the paper for creative writing or beautiful, complex sentences. It's about being direct. It's about being unmistakable.
So what does that look like in practice? A few simple rules. 1. Always write in the past tense. You're reporting on what you already did. 2. Use short, direct sentences. Be blunt. 3. Tell the story in chronological order. It just makes sense. And 4. Within each part, put the most important info first. Get right to the point.
When you really get down to it, this is what it's all about. Your single mission when writing a methods section is to hunt down and eliminate every last shred of ambiguity. You want another scientist to read it and have 0 questions about what you did. It should be impossible to misinterpret.
So let's think about this a different way. A great methods section isn't just a boring report on what happened in the past. It's an invitation. It's you holding the door open for the entire scientific community saying, here's my blueprint. Come on in, test my work, copy it, improve on it, build the next thing. It's your contribution to the future. So the real question is, who are you going to invite to build on your work?